then it might be your own system's issue. How can I fix it? I can't fix it, right? The people, other than that, for most of you, it's clear, right? So whatever I am speaking is pretty clear. Yes, no, yes, no. Okay. So see, it's clear for most of you. If anyone else is having any issues regarding audio, it's not my fault, guys. It's pretty much the issue lies in your system, not with me. Okay. Okay then. So let's go to the point where we were yesterday. Good evening to everyone. Okay. My screen is visible to everyone, I suppose. Okay. So where were we? Where were we? Mhm. We basically got this car sales data, right? And then we were exploring, I was telling you about regression and basically how you can do it, right? Give me just 1 minute before I start. Okay. So we did this random forest regressor, and then I explained you about regression. Regression is basically a concept that refers. Um, so we use it for estimating relationship between dependent variable, okay, often called outcome, and so on and so forth. Okay. So we discussed about this. Does everyone understand what regression means in general? What is happening in regression? Scikit-learn. All of you understand what is regression? Okay. Okay. Seems like there is some confusion. So let me tell you. You remember, I don't know if it is in the same chart or not. Uh, Probably it's not here. Let me see where it is. Okay, it's not here. Right. You remember this? Okay. We had this mean line going in between. We had a scatter graph, right? This, you can assume that this is somewhat a regression line. Okay. And with the help of this regression line, okay, you can somewhat guess that where your data lies. Like basically we were predicting in this scenario, we were predicting who has heart disease and who doesn't, where in 0 means like people who have heart disease, 1 means who don't have heart disease. Major, if we see this mean line, we'll see that a lot of green dot, okay, lies in this area. Okay, a lot of blue dot lies in this area. So it's not a very clear example, but it still gives you division, right? And that is what we are doing. That is what we are doing in here. For example, in here, a lot of yellows goes up in here in this section. People who have heart rate above 140, right? And you see very less number of yellows in here. This is what we are differentiating. We are creating a regression line. Okay, that's what regression does. It takes in two variables and try to have a regression line to predict outcome. To predict outcome. Okay. Okay. So that is what your regression is. Now, we did this regression. I hope everyone understands now. Okay. We did this basic regression using random forest regressor. Yesterday, we got something like this. Okay. Now, assume in this section, we had all the data, right? But what if there were missing values in the data? How will you handle that? Okay. This is also referred that you have holes in your data. This is also referred that you have holes in your data. Okay. Many I'm saying machine, many machine learning models. Okay. Many again saying many damn, many machine learning models, okay, don't work well or produce errors when they are used on data sets with missing values. Okay. So you can write most ML models do not work with missing values. Well, okay. Now, a missing value, we have seen this already. How a missing value appears. A missing value may appear as none. Okay. Now, there are two main options when dealing with missing values. What are those? One is you fill them with some given or calculated value. Okay. there are two options to deal with them. So I started early. Anyways, didn't cover a lot. I just explained what I was explaining last class, and I started just now only, which is this. It's just continuation of scikit-learn, nothing else. Haven't even coded anything, just writing it down, what we'll do. Okay. So one, fill them, uh, fill them with some given or calculated value. That is imputation. Right? This is what we have seen already. For example, you might fill missing values of a numerical column with the mean of all other values. This we have seen already. If you remember in previous class, we did it. Okay. Um, and this whole process is called imputing. Okay. Scikit-learn's documentation also has a great resource for the same. And let me actually tag it here in this notebook so that it's visible to you guys. You can read more in here. What is second option? Removed. As easy as it sounds. You just remove or omit those rows altogether. Okay. If a row or sample has missing values, you may opt to remove them from the data set completely. Right? These are the two options you have. Now, in what scenario, what will you choose? For example, if you already have a very large sort of data set and there are only few sort of data points which have missing values, you may just remove them. But assume that you have a data set where a lot of data has certain missing points. You can't remove all of them, right? In those scenarios, what you will do, you will take mean. You will take mean of it. Okay. Now, I think we might be having missing values. So we got it from here, right? Um, yes. And we have this data set. Okay. This is again that 1,000 rows. This is again that 1,000 rows, but it has a lot of missing values. Now, whoever has joined after 7:15, you can ask your friends what's the topic name. Okay, joining time was what? 7:15, right? Okay, so we have this data set, and this data set has a lot of missing values. Okay, now if your data set is large, it's likely that you will not go through it like sample by sample to find missing values. Because if we see first five, last five, we can't really observe which data point has actually missing values. Okay. Luckily, Pandas has one method. It's called ISNA. Okay. For example, PD data frame dot is NA. This is what we have that we can use. How we'll use it? Okay. Um, we should name it car sales missing actually. Okay. Car sales missing dot is NA dot sum. Cool. What it tells us basically. So it says somewhat around 50 values are missing in this data set of 1000 rows. Okay. 50 values of color, of odometer, doors, price, make, and so on and so forth. Okay. Now, what should we do as our first step if we want to do predictions? We have already done this. This is the third time we are doing it. So I hope you guys should know. Tell me fast on the chat. What should we do? What should we do? Guys, fast. Okay. Split. Correct. Okay. Split. Hmm. So let's split data. And after splitting, what do we get? After splitting, what do we get? Split data to what? To what? Split data to what? Features and labels. Features and labels. Okay. Definitely, we need to do test and training data set as well. But for in the beginning, we need to first divide our data set into features and labels. That is the first thing that we need to do. We need to divide our data set into features and table. So first we split data into features and label. Then we will convert the data. Okay. Okay. I'll tell when it comes. So first of all, let's create features. Okay. Tell me what function should come here? What function will come here? Tell me this. Correct. Correct, Pawan. Drop. Okay. We'll use drop. Okay. And what are we dropping? We'll drop price. Again, like how we were trying to do in the previous section. We will try to drop price. Okay. Now, and we know number of missing values is so on and so forth. Right. So we have this. Now we need to create labels. Okay. We need to create labels. So whatever we drop, we create label of that. Right. Whatever we drop, we create label of that. Okay. Again. Now, what do we do next? What do we do next? Look at this data set again. What did I say yesterday? Look at this data set again and tell me what did I say yesterday? Feature encoding, correct. Feature encoding. Basically, we need to convert, transform our columns into numerical form. Okay. Basically, convert into categories. So, what type of encoding we were using yesterday? What type of encoding? Past. What type of encoding? Yes, we were using hot. We were using one hot encoding. Okay, one hot encoder basically. Okay. Now, which are the which are the feature categories that we want to transform? In this column, look again. Which are the features that we want to transform? Which are the features that we want to transform? Make color door. Correct. So we want to do make color door. Okay. Then we want to initialize our encoder, which is our one not encoder. Correct. And then we want to use our column transformer, which we'll use to transform it. Okay. And if you see, we pass categorical features, we pass in our encoder, we pass the name in here. Okay. And then we say we want to return sparse matrix or not. You can explore with this. Then we say remainder, what do we need, and so on and so forth. Okay. Finally, after this step, what are we supposed to do? After this step, okay, now we have transformer. What are we supposed to do? Fast. Guys, we have already done all these steps. Fast. What are we supposed to do? That will come after that. Something has to come before split and train data. Okay. We'll just transform fit. Okay. We need to fit into our transformer. So we'll do fit transform there. Now we have transformed feature missing, everything is here. We have fitted this X features. Okay. Now finally we need to split and into training and test data. We need to split into training and test data. Look here, does this look right? Does this look right? Is this good? Is this correct? Tell me if this will work or not. Okay, let's try. Boom, it doesn't work. Why? Why doesn't it work? It says input Y contains NaN, does not accept missing values. Correct. Because we have missing values in this particular data set. That is why it will not work. Okay. To fit into our model, we need not have any missing values. To fit into our model, we need not have any missing values. Okay. So if we want to use random forest regressor, we will either have to fill in those missing values or remove those missing values. Okay. Now, scikit-learn does not have a list of models which can handle missing values directly. Okay. Such as there are few classifiers which like is gradient boosting classifier or gradient boosting regressor. Those are something that we can try, but I don't think so. So okay, let's try as experiment. No, right? Again. So scikit-learn cannot deal with missing values directly. Now, don't ask me what is this model and so on and so forth. This is something for you guys to explain, because if I start explaining every model, it will take decades. Okay. The library itself is very huge. So what did we say? How many do we have missing values? We can use is NA and then do a sum and then totally find out. Okay. Now, how can we fill, basically impute or remove these? Okay. So for categorical values, okay, one of the simplest way to fill missing fields is with string missing. Okay. So what we can do is if for categorical values, we can just simply add a type object of missing in there. Okay. And it will consider it the missing values as a separate category in itself. Okay. So missing becomes one more different category. Okay. With the numerical values that we have, for example, odometer and price, we can use mean value, like Karthik said correctly. We can use mean values. Okay. And finally, again, for price, what can we do? We can again either use mean values or we can just remove that. But since price is target value, we are basically labeling it. Okay. So we can just remove it because it will cause less harm than imputing it. Why? Because our prediction would be much more accurate. Okay. So this is how you make some sort of decision that what sort of values do you want to impute and what values do you want to remove. Okay. There is no perfect way of filling, removing data. Every time with every new data, you have to think in a very fresh sort of way. Cool? Okay. Now, let's try to fill missing values. Okay. So car sales missing, we said for make, for color, okay, we can just have seems like something is changing eventually. So this worked, but it will change in future, it seems like. Using median is better than mean value to get a, yeah, you can use median value, it's better. So there is no right or wrong answer, like I said. Okay, it completely depends. There you can't say that every time median value is better, and you can't say every time mean value is better. It is subjective to what kind of data set that you are using, and based on that it depends. And you that is why you need to analyze the data. What sort of data do you have? Okay. Um, Let me quickly search what is coming off in place actually, because they say that it will change. I also don't know. Hmm. Is it like this? Because this is what they're saying probably. Try doing this. Ah, this is what they're saying. So this is what has changed in the coming versions. Technically, this is not an error, guys. Okay, this is not an error. It is just saying that it will be deprecating. So this is the new way to do it. That is what they're saying. So I just wanted to have the new way to do it. Okay, nice. Okay, now let's see. Let's see. Make color 0. Cool. At least two columns are sorted. Now, what do we do with doors? What do we do with doors? So we can find the most common value of the doors column. Okay. And then we can place that most common value there. Okay. How this can be done in a very automated sort of fashion, I can also show you that, though it can also be done manually. Most common. If you don't introduce basically a variable, you can do it manually as well. Okay. So you see the most common is 4, right? 4 doors are basically 811, hence 4 is the most common. So what you can do, again, same thing like here, okay? You can copy the same thing, but in here what we'll have doors, and value would be what? Value would be 4. Okay. And now we can again see what's the status. Cool. Door is also solved. Cool. Now what we have? We have odometer. Now understand this. Why are we taking a median? Sorry. In here we took a median, to be honest. 4 is sort of a median. Okay. But in odometer, why are we taking mean? Because it is extremely variable in the table. It is extremely variable data point. So it's like 35, 19 years, blah, 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 blah. Hence, it's just good practice to take mean. Now, obviously, opinions differ in the community that what you need to take, mean or median. I personally still prefer in this scenario to have a mean. Okay. But do whatever you find better results from, because again, what I have said, it is a reiterative process. It is a reiterative process. Finally, we cleaned up 4 columns. What's left now? Only price, only price. And price is very simple. Remove rows with missing price labels. Okay. Car says missing dot drop NA and in place equals true. Boom. And now there should be no missing values. 100% it should be cleaned up. Right. Now, since we have removed all the sample and missing price values, there should be less overall values that we were having than before. Earlier, we were having 1000 rows, and now what we are having? We are having 950, right? Because 50 values are removed. Okay. So, again, what do? We have to repeat the process because now the data set is polished. So what do we do first? Features and labels. Guys, respond fast. Features and labels. Okay. After features and labels, what do we do? After features and labels, what do we do? Not fitting. Not selecting the model. Encoding. Categorical features, we need to encode that. Right? Make, color, those. These are the three different categorical features. Okay. Then we transform it and transform fit it, and then we get transformed X missing. Okay. Finally, split and then train data and get a score after fitting it into the model. Okay. Now do remember we get transformed X missing by fit transform, which is based on only categorical values that we get from X missing, which is what? Our features. Okay. And this is the categorical transformation. Now, in here, when we are splitting the data, we need to pass in this transformed X missing, which has our categorical value along with non-categorical values plus our label. Okay. And then we apply our machine learning model. So this fit and this fit are different and they both are necessary. Okay. And now we have 0.22 sort of accuracy, which is shit, but at least it's working, right? So at least now our data is working and we are able to work with it. Okay. We have filled the missing columns using pandas functions. You might be thinking, why are we using pandas? Okay. Though we are basically learning a lot of scikit-learn, and I showed you one method by which we can use scikit-learn and then fill in the values. Okay. Now, scikit-learn also provides a method. It's called simple imputer, via which we can actually impute this thing, okay, which allows us to do same thing that we did just now. Okay. So at this moment, our data set has no missing values, right? So we will have to re-import our missing data set to show you simple importer, which is not coming because what? Because, okay, wait, I don't come. Where is the path? Okay. Yeah. Okay. Now this has missing values, definitely. And we can go in here, look here, print here, and now we have missing values. Correct? Now, we can basically drop a lot of things. First thing that we want to drop is definitely what? It is price. It is what? It is price. So we can remove price. Okay. Now we have 950 columns. Let's see. After removing, okay, we have these many values that we need to impute. Okay. Removing and imputing are different things. I already talked about it. So these many are there which we need to impute. Okay. Now, let's first also split to X and Y before imputing. So X, we drop price and that becomes our label. We get X training data, Y training data, and so on and so forth. Right? This is the same thing that we have been doing. We are splitting data, basically getting training data, getting test data, and so on and so forth. Okay. For categorical values, it's generally okay to fill values across whole data set. Okay. However, for numerical values, you should only fill values on the test set that have been computed from training set. Okay. Now, let me write that note also for you so that it's clear. Okay. Now, training and test sets created. Okay, we have already created that. Now, what we need to do, I talked about simple imputer that we get from scikit-learn, and that is what we need to use. Okay, what we'll do, okay, we need to, for our categorical columns like make, color, we'll basically fill in values with missing, okay, and so on and so forth. So what we can do, very simple, it's not so complicated. Create categorical variable imputer, simple imputer we get from impute from scikit-learn. Okay, strategy we use constant. Okay, constant is basically a strategy that, okay, whatever, you can just read about it again from scikit-learn library. It has different sort of strategy. Constant in here just means the value doesn't change. We are just providing it a constant value. Mean means we are taking out a mean. That's it. Okay. To learn how it works internally in detail, refer to scikit-learn. Okay. Simple imputer strategy constant. Again, we are filling in value by 4. For what? Door. And then for odometer, we are basically having what? A mean. Okay. So what are different sort of categorical values in here? Let's see. So we have categorical values, we have door imputer, and we have number imputer. So 3 types of imputer we already have. Now, we need to define different types of features. So these are categorical features. This is door feature and this is numerical features, correct? You already know that. Now, how might we transform this column? How can we transform this column? Think about it. Answer me fast. What can we use to transform this column? Guys, answer. No feature encoding, man. If I already gave you the answer, how can we transform this column? Column transformer. Column transformer. that we get from scikit-learn. Okay, column transformer that we get from scikit-learn. Obviously, we followed by this. We use fit transform usually. Okay, but column transformer is the function that we'll use to transform this column. Okay, so we have now transformed this column using the imputer and the features that we wanted to transform. Okay, we are filling in the value. Now, why are we doing this way? We are not calculating. So firstly, in our case, we're not calculating many variables except the mean, right? However, remember that the test set should always remain unseen. Okay, we don't want to see that data. Okay. Secondly, uh, when filling values in the test set, they should only be with values calculated or imputed from the training sets. Okay. Let me also write it down. So when filling values in the test set, they should only be with values calculated or imputed from the training set. Okay. Now we can achieve this whole thing. Okay. With what? With now fit transform method. Achieve what? So this is a three-step process. Basically, this is a three-step process. Basically, this. Learn the imputation value from training set, fill the missing values in the training set with values learned in one, fill the missing values in testing set with values in one. Right? Okay. Cool. So first, when I say we need to keep in mind that we need to keep test data unseen, and hence why we will have to transform everything separately. Okay. So do remember in the first one, we'll use fit transform. Okay. One. Correct. This is for what? Training data. Then when we are working with test data, we won't use fit. When we are working with training data, we won't use fit. Okay. Guys, give me 1 minute. I'll be back. Guys, sorry for being off. Give me 1 minute. Okay. I don't know what happens to my camera every day. It's fine. So let me share back my screen. Is it visible to everyone? Is it visible to everyone? Yes, no, yes. Okay, cool. Blackbucks website. I don't know, man. Blackbucks website and so on and so forth. Okay. DM anything Blackbucks related to the host Blackbucks. Okay. Not me. Cool. Okay. Now, do remember for test data, we use transform. For training data, we use fit transform. And then we can see our training data as such. Cool. Works, right? Now, we need to get our transforms data in a data frame format. Same for our test data, we need to get it in a data frame format. The reason for that is it's just easier for us to work with data frames, right? And that's why we convert the X-train into a data frame. We convert X-test into a data frame. Okay, with these four features that we have already seen. Boom, we have no missing values now, right? We don't have any missing values. And there, cool. And if you see the original one again, you see that original one had these missing values, but the filled ones do not have any missing values. Okay. Is our data all numerical? Let's see. Okay, no. Looks like make and color columns are still strings. So what do we need to do? We need to again do the same process of transformation and stuff that we did earlier, right? To transform it. Same thing again to transform it. Okay. And now we should have our transform data, which is all numerical, right? That is the data that we need. And finally, we can use our random forest regressor. And what do we get? 0.21 something. So you will notice that the result is slightly different than before because, okay, because, tell me why. Okay. This is coming 0.21 and earlier when we actually created our model, we were getting 0.22 something. Why is that? Answer me. No. Even then we converted all columns to numeric. Like when we were not using simple imputer, we also converted all columns to numeric. It is just that we were omitting everything one by one using pandas. And now we use scikit-learn. Answers? No answer. Okay. The answer is training data and test data set is now different, right? We saw this yesterday that we were doing this cross validation with 5 different data sets and we were getting different sort of accuracy. And this is what also happened here. We are using, because we use different method, the data set is somewhat different than what we were having before. Okay. Previously, what we were doing was we filled in missing values before splitting the data into training and test sets. Okay. And this time we did it differently. Okay. So previous method actually might lead to information leaking, okay, into test set. We were not really careful to separate like test data and training data. If you remember, earlier we just separated everything at once. Okay, now we have done a lot. You can look at this notebook later. But in the earlier method, when we were doing this with pandas, we basically separated everything like all together. But now we clearly made a distinct assumption with test and training data set. Right? Okay. Now, you need to remember always, okay? You need to really remember, always remember that training data should never have redundancy with test data to actually get your answers, accuracy, and so on and so forth. Okay. So there are a few points that you need to keep in mind. Namely, so okay. So one is keep your training data and test sets separate. Most data sets you come across won't be in a form ready to immediately start using them with machine learning models. Okay. Hence, and may take more preparation than others. Okay. Then for most machine learning models, your data has to be numerical. This will involve converting whatever you are working with into numbers. This process is often referred as a feature engineering or feature encoding. Some machine learning models aren't compatible with missing data. The process of filling missing data is referred as data imputation. Got it? These are the 4 things that you really need to remember. Okay. Now, once you have your data ready, what is the next step? Up until now, we made the data ready. You see that, okay, we are basically polishing our data, cleaning our data, so on and so forth, making it ready for applying a machine learning model and so on and so forth. What is the next step? Guys, what is the next step? So next step is basically to choose the right estimator algorithm, okay, for our problem. Once you have the data ready, we need to basically find correct machine learning algorithm or pattern to use our data set. Okay. Some things that we need to know. One, circuit. Firstly, this I have told all of this already, but you need to note that okay, hash 2 choosing the right algorithm. Okay. One, scikit-learn refers to machine learning models and algorithms as estimators. Okay. Two, classification problem, predicting a category, for example, heart disease is there or not, or sometimes you will see CLF, short for classifier used as classification estimator instead of variable name. This is very general practice. Okay. Regression problem. Regression problem. What is regression problem? For example, predicting a number, selling price of a car. Selling price of a car. And that is regression problem. Okay. Unsupervised problem. What are those problems? Basically, problems with no labels. Okay. You have data, but you have no labels, and we need to do some sort of clustering. Okay. Um, so learn. What is that? ML map dot png. And this is the cheat sheet that you need to follow. This is the cheat sheet that you need to follow. Okay. Scikit-learn algorithm cheat sheet that you need to follow. Now you can see it's split into four main categories, which is obviously regression, classification, clustering, and then dimensionality reduction. Each has their own different purpose. Okay. But the scikit-learn team has designed the library so that the workflows for each are relatively similar. Okay. Now, how do we pick up? How do we pick up the right machine learning model? Now, let me see. Do I have all the data set that I need? I think I might be missing some data set, something like that. Okay, it's fine. It's fine. We'll work with what scikit-learn provides. Okay, so let's try to understand how do we pick up. Okay, let's try to here itself. Let's try to understand. Okay, picking up ML model for regression problem. Okay. So let's start with regression problem, trying to predict a number. And what we'll use is we'll use a California housing data set. This is already present. This particular data set is already present inside scikit-learn data set module. So scikit-learn also has some dummy data sets that you get to actually test and learn. Okay. And this is the data set that we use. The goal of California housing data set is to predict a given district's median house value. Okay. What is the median house value in a particular district? For example, if you are living in some sort of locality, maybe Hyderabad, Vijayawada, Kannur, or what all places are there in Andhra and Telangana? Kurnool and what all? Visakhapatnam, Vizag, and so on and so forth. Okay. And you want to get uh, average median price of your properties. Okay. Similarly, we are doing it for California. Sadly, Vijayawada and Kurnool is not available by scikit-learn. So we'll use that data. Okay. Okay. So and there, right? So first of all, we'll get this data set. This is already there in what? Scikit-learn. Okay. Now what this will do, it will download it as a directory. It will download it as a directory. If I reload it somewhere in this directory, it will download this data set. Slowly but slow, sure, okay. Maybe it gets downloaded up until the point. Let's see. Okay. And then we have cool. We already got our data set. Okay, it's downloaded. It's downloaded. We have our data set and we can see top 5 values. We have a lot of numbers in here, basically. House age, average rooms, average bedrooms, population, average occupation, latitude, longitude, target, so on and so forth, right? So we have a lot of values in here. Let's see what is the size of this sample. Let's see what is the size of this sample. And it says there are 20,640 rows or data points. Okay. Cool. So now what is our goal? Our goal here is to use the feature columns such as medium income in block group, which is this. Okay. House age, which is this. Okay. This is all median, right? Median house age, average rooms, and so on and so forth. Okay. What we need to predict? We need to predict target column, which expresses the median house value for special California district. Right? This is what it gives. Now, okay. Let's choose our model. We have seen this. Now we want to choose our model. Let's try to choose our model. So this is how we'll do it. So we know, okay, we have 20,000 plus sample and we want to understand what model we need to use. So what we do? We start from here. Do we have more than 50 samples? Yes, we have. Okay. Then what sort of category do we have? Are we predicting some sort of category? Then yes, we are predicting some sort of category. Okay. We have a category that we need to predict. And we have so many categories up in here. Sorry. Uh, do we have a category? No, we don't have a category. Earlier, like we were having a category before this. like doors and so on and so forth. In here, it's all numbers, right? Median, house age, average rooms, average bedroom population, and so on and so forth. So we don't have a category. So no. Do we have a quantity? Yes, we have a lot of quantity. We have basically number of rooms, average bedrooms, we have number of population. So we have a lot of quantity in here that we need to analyze. So yes, do we have less than 100K sample? Yes, we have less than 100K sample. Then do we have few features? Are there few features which are important? Yes or no? We are not sure what features are important or not. We are not sure. Okay. Because we are not sure what we'll do, we will just pick up one regression model that we might feel, okay, it is good. So we'll use ridge regression, and that is what is coming out to be. Now, there are several other regression models that we can use, but as per the map, we are getting a suggestion that we might be able to use ridge regression. Cool. And how we can import? So we have a linear model. We can get ridge regression as such. Same process again, split into label, split into features. Okay. Yes, whoever is saying sir, can just type what? Okay. X train, X test, X Y train, Y test, train. Again, this whole split and train test, again repeating the same thing. Finally, in this process, we will use what model? We'll use ridge model. Okay, and we'll try to fit in the data with our training data set. Correct. This is what we have been doing up until now. And then finally, with our finally, we'll try to get the score with our test data. And here, if you see, we get what? 0.57585, whatever, okay, with ridge regression. Now, it didn't work, right? Or we want to improve this result because 0.57 is not really good result as a prediction param. It is not a good result. So following the diagram, the next step would be what? Following this diagram, what would be next step? So let me get another diagram. The next step would be to use another model. So ridge regression doesn't work. So maybe we can try ensemble regressors. Okay, we can try ensemble regressors. Now, ensemble is another word for basically multiple models. So inside ensemble regressors, there are plethora of models that we can try. Okay, one of the most common and useful ensemble method is obviously random forest. Okay, it is very popular and it is basically known for its fast training and prediction times. Okay, and adaptability to different problems. Okay, basic premise again. We have been using this, but you don't know what is the basic premise. So the basic premise of any random forest is that we combine number of decision trees. Now you can look into what is a decision tree. Basically, each one random from the other and make a prediction on a sample by averaging the result of each of these decision tree. Okay. Now, I'll add again a good explanation on what is random forest. You can read this blog. It is a very good blog. Probably can help you a lot. understanding random forest in general. Right? So now let's try to use our ensemble algorithm. So we use random forest. We have already seen all of this. Repeat the same steps that we need to do. Apart from the only fact is now we are using random forest regressor as our model and we are fitting into it. And let's see what score do we get. Oops. Hmm. Eh, we got it, but we got it late. So yeah, we are getting what somewhat 80% of or something sort of value. This is what we are getting. Okay. Now this is good, right? This is good boost. Earlier, what we were getting with ridge regressor, we were getting 57 or something. And now what we are getting 80%. You see how we have improved, right? Now, applying the same principles, applying the same principles, what I want you to do as a take-home assignment is on a heart disease data set, you will try to experiment with different sort of classifier algorithm. Okay, that is your take-home task. You will try to experiment with different type of classifier algorithm. Okay. Hmm. Okay. So guys, anyone has any questions up until now? You can ask me. Any questions? I'll wait for 2 minutes for any questions to come. Okay. Linear regression is used to predict continuous variables. Logistics is used for predicting Boolean yes, no. Similarly, for what ridge regression is used. So ridge regression is basically used for regularization, which means that basically it helps when um, helps correcting overfitting on training data. Okay, so it is usually used for basically error corrections. Okay, some data might be having like a lot of high weight and so on and so forth. So in those sort of scenarios, this is used. Okay, you can read much more in detail about ridge regression. It's already there, but this is a basic sort of thing. My voice is not clear. Is my voice not clear? Because I was not even saying anything. Is my voice unclear, guys? Yes, no. So my voice is unclear. It's clear. It's clear. Okay, it's clear. If it's clear, then basically um, it might be somewhere. Yes, I gave you time for asking doubts. Okay. Can you show an example of inputting data and predicting the outcome value? We were doing that up until now. We are doing what we are doing. We are inputting test values anyways. Okay. You can experiment a lot. सर मुझे एक भी बात समझ में नहीं आ रही कि साइकिट लर्न से क्या करूं. So शिवा, scikit-learn say basically you import any sort of model. See, every time we are repeating the same process. Okay. Every time we are using the same process, which is random seed housing. Sorry, random seed housing, I'm saying. Basically splitting data into features and all. Right? And then we choose some sort of model based on the data that we have and the things that we want to predict. And based on that, we fit our data into that model after we have divided things into feature and labels. And finally, we get a prediction score. The test data that we are providing in here is mostly what we will provide as a user eventually. Okay. So it says, okay, 80% of the data is correct. Okay. Okay. So if you remember, we already did this whole cross-validation stuff, right? We did this cross-validation stuff. By the way, if you want to predict only one model or something, you can do that. Okay, you just need to, uh, for example, you have this model, and when you do model, okay, you can do something like model dot predict. And then you can do, for example, test. And this is only first row that I'm trying to predict. Cool. And we get some sort of prediction out here. Okay. So what you can do, if you want, you can create a single line sort of data frame or something. You can transform the data that you are getting from users into a single form of data frame and then directly pass it to this model.predict. And hence you will get some sort of prediction out of it. Now, there are two types of predict actually. Okay. One is obviously the predict. Okay. And another is predict proba. Okay. What is predict proba? It returns a five arrays, a return as array of five arrays. Okay. And each contains basically two values. Okay. Sorry, five arrays, I'm saying. I'm sorry. It basically returns two values. Okay. Not five arrays. It returns two values. And how does it work? For example, we have this predict. And now if I want to have something like this, I cannot use proba on regressor actually. This is present in classifier. This is present in classifier. So when you will do your heart disease stuff, you will probably be using some sort of classifier, and you can test this predict proba. So what does this do? Okay, it basically gives you some sort of probability. Okay, so assume if you have an array, you get this as an output. Let me tell you, we get this as an output. So assume 0.89 is your prediction, okay? While the second part is some sort of probability score, okay? That what is the probability? The highest probability score of something is, okay, that you can actually get out of this prediction. Correct. Gives the probability for getting 0 or 1. Couldn't have explained it better. Gives the probability for getting 0 or 1. Cool. So that is what predict proba does. Finally, I think so tomorrow we'll go through how you evaluate your model. Okay. But I want you guys, okay, expression, regression, basically you need to read it yourself. That's all I can say. If I start explaining every model present in scikit-learn, it will take a lot of time. I already told you that it basically helps you when you have a overfitting sort of model, when basically weights of certain feature is a lot, and that is when you try to use rich regression. Okay. Okay. I think so. I have covered most important parts in scikit-learn, and there are now only few parts that will be running through. Okay. I'll give a lot of notes around it. Okay. And tomorrow, basically, or whatever is the next class, we'll be running through all of this. Yeah, we'll be running through all of this. And finally, we will start off with deep learning. Post that. I'll still not share notebook today because I want to share you this complete scikit-learn notebook once it's done, okay? Which will be done in next class after we talk about evaluation and all. And then I'll instantly share, okay? No, I can't explain more regression because that's not part of the course. I'm sorry for that, MT, because I think you need to read, you can just read it by Googling. Okay. I already explained it in simple terminology, ridge regression. How simple can I, who do you want me to explain? I am, okay, what I'll do is I'll basically attach a good sort of explanation for ridge regression. Okay. If you actually go through, if you actually go through scikit-learn's documentation itself, you'll get it. Okay. And then there is one whole paper on ridge regression that you can actually refer to. Then I'll attach it with you. Okay. So again, basically, sometimes there are too many features or predictors. Okay. That is what we call as overfitting. And have to basically solve that problem where you are not getting a proper X, which is our features, that is when you use this sort of regression model. Now, there is a lot of maths involved in it to properly explain you, which is not part of this course. That is what I am trying to explain you. Okay. Yes, Roshan asked the question. I don't know. You can ask that to Blackbucks. So understand, guys, you only need to know high level understanding of any model for now. Okay. If you want to understand low level understanding of any sort of model, then you need to know very advanced mathematics. Okay. Which is basically you need to know good level of probability. You need to know good level of integration and Bayesian theorem and so on and so forth to basically understand in depth of any sort of model. Okay. Even for regression, for this one, okay, for this paper has a lot of maths. If you will read it. Okay. Tomorrow it will take only half an hour for me to rush it. Please do a fitting exercise with heart disease model. I think by now all of you have that data set. I have pretty much sent all the notebooks except this one. This SKLearn notebook is the only one that I haven't sent. Other than this, I have sent it to everyone, all the notebooks that I have prepared. Okay. Secondly, I also saw some people were asking for PDFs. When I am sharing you this Jupyter notebook, why do I need to send you PDF? And I'm saying this, I'll share you this notebook tomorrow. By then, do heart disease model thing, okay? Try to apply the same sort of stuff that I have applied here on heart disease model for a classification problem, okay? Tomorrow, within half an hour, we'll be done with scikit-learn. It is, I don't know when is the next class. It's tomorrow or day after tomorrow. Whenever it is, we will be done with it. And then we will work with deep learning. Someone asked here, what is the salary package or something? Completely depends on your skill. You might earn as low as 0 rupees to as high as 50 LPA, 1 CR, depending on your skills. If you want a good tip from myself, I'll say the best tip that I can give you is be active on Git, GitHub. Okay. You need to be active on GitHub. You need to understand Git. Okay. And when you write or do any sort of experimentation programming or something like that, start contributing on GitHub. Maybe, for example, also start exploring Kaggle. If you want to make your career in machine learning, go to Kaggle. You will get a lot of data sets and all. Start applying. It is all recursive process. You just need to know, again, you just need to know high level understanding up until now. But if you really want to dig deep into everything, then you will have to do a very in-depth sort of a statistics course. Okay. which is definitely not part of this course. Hence why I'm not explaining a lot in depth. For example, uh, you keep asking me ridge regression, but I can't because then I'll have to dive deep into maths to explain you. And then you will ask me how that math works. And I can't explain you because that will take again 2 more class. Okay. No other questions to anyone, right? I'll drop. Bye, guys. Tell your friends what is the topic name. Tell your friends what is the topic name. Today it's like fruit punch via organic farming. Someone's name is Kill Bill Pandey. Kill Bill Pandey. Pandey. Ta, 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 ta. Okay, guys. Bye. I think no one has any questions. Yes, definitely. I'm a fan of Allu Arjun. Okay. I'll share notebook tomorrow 100% because we'll be done with SK. Okay. Sir, how much is your salary? I don't have a salary. I work for myself. I pay myself. Okay. So I'll be sharing this notebook definitely. Uh, Probably day after tomorrow. Right. That is why I'm not sharing you. And obviously, if I'm sharing you Jupyter notebook, please don't expect a PDF. Okay. See you guys. Bye.